Good morning, everyone, or good afternoon, depending on where you are, and welcome to virtual ChefConf. So today I'll be giving a talk about using Chef and Consul together. Consul is an open source service discovery and service mesh tool, and we have a nice virtual studio audience here, and some of you may hear this asynchronously as well once the recording is posted. If you have questions, just use the little Q&A button at the bottom of your Zoom window, and we'll kind of save the questions up till the end of the lecture and demo, and then tackle all the questions together at once. Maddie, would you mind turning on screen sharing?
Yep, you're good to go. Sorry about that.
No problem. All right. So you should be seeing my slide deck now. It says easy multi-node configuration with Chef and Consul. One of the things I love about Chef is that it's a very flexible configuration tool. It's just basically Ruby, right, or customized Ruby. So whenever you need to, you can actually integrate with external things or pull in a Ruby gem here and there. So we'll do some of that today and show you how you can use Chef and Consul together to configure multiple nodes or check the health of services. Before we dive in though, I think an introduction is in order. My name is Carolan. I am a technology specialist with HashiCorp. In my past life, I actually worked at Chef, was a solutions architect, solutions engineer there. And prior to that, I was a systems administrator. So a lot of experience building, configuring servers, doing DevOps. These photos here were taken at Austin Comic Con last year. So when I'm not in front of the computer, doing things like this or spending time outside. So back in the day, as I mentioned, I was a systems administrator and got my first gig here in Austin, Texas. Was really excited to go to work with this new environment that I basically was inheriting from another user. And I had dreams of a neat data center cage, looked something like this. All the, everything correctly labeled, everything plugged into the right place. This is the dream, isn't it? But the reality, while not quite this bad, it was almost this bad. It looks sort of like spaghetti. This is the type of environment that you may be afraid to touch anything because you don't know what's connected to what. And interestingly, as we've moved to cloud, we still have this problem, right? Things are hard to keep track of when you have a lot of change in your environments. So whether you're working with physical data center and cables or a cloud environment with APIs, the fact is it's challenging, it's hard to keep track of everything that's there on your network and what its IP address is, and is it a healthy service or not? So Consul actually aims to solve this problem. And today I'm going to show you how you can use Chef and Consul together to solve problems that either tool might not be able to tackle alone. So Chef, as we all know, it's a great, powerful open source configuration management tool. There's the Chef language and the Chef server. Many of you have the Chef Automate suite, right? And the Chef Infra tool powering your infrastructure. Chef is great for configuration management. Consul is actually a service discovery and service catalog tool. So they serve slightly different purposes. Don't think that Chef and Consul are competing with one another, because they're not really. They complement each other really nicely. Chef does configuration management really well, and also compliance, scans if you're using InSpec. And Consul helps you keep track of all of the stuff that you built with Chef. So you can use even Chef to install Consul and configure it, and then you can use Consul to keep track of all of your services and things running on your network and feed that info right back into your Chef recipes. So these two go really well together. Everything in this presentation, by the way, will be open source. So I'm not here to sell you anything today. Consul is our most popular open source tool, and you can get a lot of value out of it without using the enterprise version. So some of you may be old enough to remember these early commercials for Reese's peanut butter cups. They involved often strange, combinations or scenarios, like people walking down the street and, eating a jar of peanut butter, like right out of the jar with a spoon. And the boy bumps into the girl, like, oops, he drops his chocolate into the peanut butter. And then they together discover this, great combination of chocolate and peanut butter. So I thought of that when I was putting this talk together. What can Consul do for you as a chef user? Well, here are 3 of the things Consul can do. It's more of a Swiss Army knife than a single purpose tool, but these are 3 of the most popular use cases for Consul. The first one is service discovery. This is a problem that anyone who works with applications or networks is going to run into sooner or later. And service discovery is all about answering simple questions such as, where are my applications? Where is my database? Where is this other external service? What IP address? And what port is that service running on? Is it accepting traffic? Second use case is health checks. I'd like to know, well, which instances of my application are healthy? What's ready to receive traffic? Because I don't want to send traffic to an unhealthy instance or service. And then finally, Consul has a distributed key value store where you can store any type of data required for infrastructure or application builds. This is a powerful feature. You could store things like blue-green testing flags. You could put application version numbers. You could store an entire manifest for your application inside the key value store. And then the beauty of all this is that it's instantly accessible to any node on your network. I'll show you how that works. We're going to go over Consul quite a bit because assuming that this is ChefConf, most of you probably know a little bit about Chef. Maybe not everybody's deeply familiar with Consul yet. So we'll cover Consul and how it works so that you can understand better how it will fit into your Chef world. Let's start with Consul components. What are the main parts of Consul? Consul is a distributed system. So it's designed to run on a cluster of nodes or an entire data center, could be even an entire cloud region or location, or multiple locations. You can actually have multi-data center connections between different Consul clusters. But the base, unit of Consul is one data center, one cloud, region with a bunch of nodes all connected together in what we call this gossip ring or gossip protocol. If any of you have used Habitat, you might have heard this term, the gossip protocol. What does that mean? Well, like gossip in school or in a workplace, it's people whispering things to one another. So in the technology world, it's your machines passing bits of information to their nearest neighbors. Think of a giant network of stuff all connected together, and node A can talk to B and C. B and C can each talk to D and E and F and G and so on. And in this way, you form sort of a cluster or an intelligent, semi-intelligent mesh. It's like a mesh network. Consul is a single binary. You could call it an agent, and it sits on each and every node in your network. Just like the Chef client, we also have a client for Consul. And the job of the Consul client is to always provide up-to-date data to you and your applications. So that data might be from the key value store, it might be a health check, it might be needing to know where an IP address or a port is. All that stuff is instantly accessible to any node on the network. The agent itself can run in 2 modes. So it's the same software. If you want to download Consul, it's really easy. You can just go to the Consul website. And we have it for several flavors of OS. can see I can get it for Windows or Linux. And the console client, console server, same exact software. So the only difference is the config file. If I tell the config file you're a client, then the client is simply going to forward requests and query the servers when they need to ask for some data. And the servers are maintaining the source of truth for all the service discovery and information that they have to store. Now that client, again, is an agent that runs in every node where you have services. And that client can actually check the health of those local services and then share the health check with the servers so that other machines on your network will instantly know, hey, is the database up? Is it healthy? So very powerful feature. The server is also running the same software. It's an agent, but this is where state is maintained. And in a typical console network, you'll have usually 3 or 5 servers. Those are kind of the optimal numbers. 3 for a smaller network or dev test, 5 for a larger, more robust configuration. The reason the numbers are odd is because we need quorum. Quorum means you don't want a tiebreaker vote where 2 servers say one thing, 2 servers say something else, and there's no one to break the tie and pick a new leader. So odd numbers, 3 or 5 typically are the number of servers in a garden variety console network. Now, the set of console agents all taken together, that includes servers and clients, that's called a data center. There are some pretty strict requirements for using console in terms of your network, and they're listed here. So first of all, low latency. You need to have your nodes really close together, basically. For most people, that means inside the same data center, or in a cloud environment, you can often spread your console servers across different zones, but it's got to be a low latency link. So what do we mean by low latency? We're talking like 10 microseconds or lower. So don't try to spread your console data center across 2 physical locations unless you absolutely know that you have a super fast network link between the 2. And by super fast, we mean less than 10 millisecond ping times between the nodes. You also need high bandwidth. Console is meant to run, again, on a local network. So you want to have pretty unrestricted high bandwidth between your nodes. You also want unrestricted communication. Now, security people out there, I can hear you freaking out, going, oh my gosh, no, we can't have unrestricted communication. We have some safeguards in place so that it is not a total free-for-all, and it will not overload your network. All right, so here's an architecture diagram showing clients and servers inside a data center. Now, we only have 3 clients. In the real world, you could have hundreds of clients or thousands of clients. And the beauty of the gossip protocol is that even if you have huge numbers of nodes, tens of thousands of these, it scales really well. You can update all of them within seconds, usually, less than a few seconds. So this is the communication. You have gossip protocol between clients. You have communication between clients and servers. And you also have communication between servers and servers. Why do we have 3 servers? Well, it's in case we lose one. If you have 5 servers, you can lose 2. This is to ensure that you have high availability and that you don't, take down your console cluster by the loss of 1 server. It also helps for upgrades. If you'd like to upgrade, you can kind of do a rolling upgrade and do 1 node at a time. So that's a data center. Now let's talk about what console actually does. We looked at how it's structured. Let's look at how it does service discovery. This is the challenge. Everybody has that spreadsheet, or sometimes it's a CMDB. Think of that spreadsheet. This is the giant spreadsheet where you keep track of all of the machines on your network and all of the services and maybe what ports and IPs they're running on. Almost every shop that we run into has some version of this thing. And the problem is that it's not always up to date. Now with dynamic environments like cloud, things are moving around all the time. IP addresses are changing. It makes it very cumbersome to do fast configuration management and DevOps when you have to go and look stuff up manually and do a bunch of manual steps to fix an IP address. So that's the challenge. How do I automate this stuff when I don't know exactly what it's going to be day to day? So we'll cover an overview of Consul service discovery, how to register new services, how we discover services, and then talk a little bit about health checks. Consul is a decentralized registry. So instead of a hub and spoke model, now you have this distributed cluster where any machine on your network can query the registry really easily. There are a couple different ways you can talk to Consul as an application. The first is the simplest. It's the DNS interface. So Consul by default offers a DNS-based interface where you say, can you tell me where app.b.service.consul is? And then the server goes, well, of course, it's right here's the IP address. That was the last IP address it was seen at. And it's simple as making a DNS query. No extra software required to be installed. If you want to just talk to a DNS server, you can use Consul. The reason we designed it this way is for maximum compatibility. So pretty much any application in the world can speak DNS, right? We all understand what a host name is. So at the lowest level, you can get basic service discovery information out of Consul using DNS. DNS is a little limited though. I can ask for a host name, but I don't get a whole lot more than that IP address. Maybe you could query a text record or something and get some more data. But sometimes you need more power. For those use cases, we also have a RESTful API. And this gives a lot more rich information about services, about key value data, about the nodes on the network. And it's just a standard HTTP API. So if your application can speak HTTP, then you can also work with Consul. It's designed for maximum compatibility with just about any type of app or service. It also offers some neat features like automatic load balancing. If you have a simple scenario where you just want to send traffic to healthy nodes and you don't really care too much about sticky sessions or advanced load balancer features, Consul's got your back. You can just register a whole bunch of services and then they'll all turn up in the DNS query or your HTTP query and automatically kind of route traffic to one of those nodes. Really simple. We have users who have eliminated thousands of load balancers that really all they were doing was just sending traffic to healthy machines. You can do that in software with Consul. It's pretty easy to accomplish. And we also have health checks. So you can actually exclude unhealthy nodes from even being seen when applications query Consul. They don't get a connection to a node that's gone bad, for example. So you can help prevent outages and issues that way. How does Consul learn about services? So this is important to understand about Consul, is that it's not going to crawl your network and look for services. That's not what we mean when we say service discovery. You do have to register services that you care about. It's pretty simple, actually. You create a little config file, and I just happen to know of a tool you could use to render that config file. Yes, you could use Chef to render your Consul config templates. So that's pretty easy. Drop the Consul binary in place, render a config file for this service, boom, it's registered, and the health status of that service is now available to everyone who can talk to your Consul network. You can do this a few different ways. You could use a config file, as I mentioned. You can use a CLI, or advanced users might want to just go straight to the HTTP API. You just make an API call, feed in the correct data, and then your service will be registered. So this is an example of the config file. These can be defined in HCL, which is HashiCorp config language, or JSON. Both formats are fine. One point to watch out for, Consul does load that config directory upon startup. However, it's not watching that directory. So if you drop a new file into place to configure a new service, you want to issue a Consul reload to load new changes. You could do that with Chef too. You could have Chef issue the Consul reload for you the next time a new service is registered. Here's a simple command line example of a registration. We're just feeding the data in as a file, as a payload. Same thing with the command line tool. You can use Consul as a client, a server, or even as a command line interface. So it's a very flexible tool. And then if you wish, you can have multiple instances of a service per data center. Maybe I have 5 or 6 web servers, and then behind that, you might have a bunch of database servers. Consul can load balance across instances. There is one restriction. You can only have one instance of any service per node, because having multiple instances of a service per node is a path to insanity. Don't do it. If you need this, just name it something different, right? For your own sanity's sake, give it a different name. This ensures resiliency. It also helps us avoid port conflicts. Now, how does Consul return service locations? This is a good little diagram that sort of illustrates it. First of all, you want to register your service. So we've done that here. And then once the servers have that data, it's accessible to the other machines in the network. This one over here on the left is doing a dig command. I could also easily just do a curl or any type of API call to get the same data. So you don't have to use the DNS interface as we're doing here. And then it returns the IP address of the healthy Redis instance. Here's an example on the command line. You can just use a tool as simple as the Unix dig command and get valid data from the service catalog. Now, there is a naming convention that you want to be aware of. For DNS style queries, the important bits are highlighted in pink here, or the tags are highlighted in pink. Those are optional. And then the required ones are the service, the DNS suffix. The default here is Consul. So what I'm saying here is give me the Redis service called DB or tagged with DB in data center 1. And this is a handy little cheat sheet. These slides will be available afterwards as well in case you want to review this later. .consul is your top level domain. The .node namespace is for information about all the nodes. .service is for those services. And .query is a special one that I don't have time to cover today, but it's really neat. Go look it up if you want to. It lets you do all sorts of logic in your DNS queries. So you could do things like failover if the first node wasn't healthy. This is a really neat trick too. One of the ways you can integrate with Consul is to just have it be a DNS resolver on the local system. And this makes working with Chef really, really easy because now you can simply rely on local DNS names to find things that you care about. It does require a little tweaking to your DNS resolvers, but it is a super cool, very slick integration that is very low touch once you get it set up on your on each of your nodes. In essence, what you're doing is creating another subdomain called .consul, And .consul is special. It's like metadata. You can query the .consul domain now and get information about anything, anywhere on your network, including its health status. And we do have some workshops. We don't have time to go through these workshops during the talk today, but these are self-paced. You can do them on your own. So if you like, go ahead and kind of jot these URLs down or copy them down. I'll put these in the chat too. I think we have a chat, right? All right, we'll make the slides available after because I don't see an easy way to drop them in chat. So these two will get you up and started with Consul and the basic concepts. And then for the rest of the talk today, I've got a little sample code repo where we finally get to show you the peanut butter and chocolate together, right? Chef and Consul working together. So let's jump over to a live demo. And we'll start our journey with the app, because that's what everybody cares about. Our app is called HashiCat. And the HashiCat app produces pictures of kittens, kittens as a service. We're using the kitten API, what is it called? placekitten.com to grab different photos of cats. Let's see if I can make this a little bigger. Also known as the Meow World application. As you expected, we deployed this with Chef, of course. And the repo is here. It's called ChefConf-demo. Let me walk you through kind of the thought process and how we built this recipe. And then we'll go ahead and run it. Hopefully that text size is large enough. So the first thing I did was search Google, because that's what we do. I wanted to see if there was a Ruby gem for Consul. And I was surprised, actually not surprised, I was happy to find out that someone did create one. It's called Diplomat. It's kind of cool. Now, you don't have to use Diplomat to interact with Consul, but I figured, hey, if someone's already written a Ruby API, why not? Let's try it out. So this is the Ruby gem, and it's got some examples. Really pretty simple. We're just creating a new Diplomat object and then either putting data into Consul or getting data out of Consul. So we use Chef Gem to install the Diplomat Ruby gem. We want to require it so we can actually use it. In fact, I think I have a commented version of this. Here we go. This is pretty basic Chef. Everyone remembers their package service template basics. We're installing the Apache package. On Ubuntu, it starts automatically, so I didn't have to put service start. And now we're getting into the interface between Chef and Consul. I want to fetch application configs from the Consul key value data store. And in this case, I'm fetching 3 pieces of data: the placeholder, the width, and the height. If I hop over here to my Consul UI, I can see those in key value. Height, I could change this to 600. Width, because I'm an admin, I'm allowed to edit these. And then the placeholder you see is simply www.placekitten.com. Those values get pulled in here from the local Consul agent. Now we have to do a little bit of Ruby here because we want to make sure a database instance is actually up before we go on and finish this Chef run. So we're using a simple Ruby block to say, check my service health for the HashiCat database. And if it's not passing, just keep looping through here. Now I would clean this up a bit. This is definitely an art of the possible demo. You probably want to have it stop after, a certain amount of time. But basically the idea is wait for the database to be up and running, which means it's showing as healthy in Consul. Then we simply grab the database IP address, which is another diplomat call. And then we render a template. Simple chef template with some template variables. Why do we use lazy? Well, we want to wait until the very, very end of the chef run, basically, to try and get this data, right? We don't want to try to fetch it at the beginning of the chef run because the database might not be up. That thing might not even exist yet. So that's our simple chef recipe. Let's go ahead and give it a run. So pretend this is our configuration. The database has just been moved. It's moved to a new IP address. And if you bear with me, I'm going to share my whole desktop. We'll kick off a chef client run. And you can see it's kind of paused here because database isn't running yet. This is my database server. And if I look over at services, it doesn't show any database in the service catalog. Let's go ahead and fix that. First thing we're going to do is start Consul. And then we should see the service get registered pretty quickly here. There it is. Okay, it beat me to the punch. Service is registered, but we have a little problem. It's not healthy. That's because the database isn't actually running. If we check back in on our chef run, it's still hanging out, waiting for that database. Fire up the database. Now the next thing we should see is it becomes healthy. You see how quickly that happens? It's amazingly fast, this swarm type communication. It propagates across your network, usually in microseconds. And that unlocked the chef run to finish and actually go ahead and update the IP address to the correct IP address. And as you saw, because we changed the dimensions of the image, we got a new cat. Now there's some other neat features that I mentioned you can use Consul and Chef together for. Let's say I just want a place to park some application configs, right? Like the height and width of my things. So let's just change that to 700. And for width, we'll do 1,000. We'll get really crazy here and change our placeholder too. One of my favorites, philmurray.com. It is exclusively pictures of Bill Murray. Next time Chef client runs, it's simply fetching those pieces of config data straight from the Consul catalog. And I can reload my website. Should get a picture of a very distinguished Bill Murray. So this presentation is just a taste. It's really meant to give you an idea of what Consul can do and explain the art of the possible. We showed a couple of use cases. One is dynamic discovery during the chef run of another service on your network. And that could be another machine that's being built, or it could be a machine that already exists. And dynamic application configs, and an easy way to get them into your chef runs by using the Consul service catalog. So I'll leave these links up. These are some fun tutorials you can use to spin up your very own Consul server and play around with it. And I think that brings us to questions. So let's go ahead and open it up for questions. I have brought along a coworker. I'm not sure if he's in here. Okay, he may or may not be here. Oh, panelists, there you are. Oh no, that's not him, that's Mandy. Okay, it'll just be me then. So if anyone has questions, pop them into the Q&A.
Yeah, we've got one to start.
I got it.
We've got one here. Within an AWS region, can a Consul cluster span multiple availability zones, or is there too much latency for that?
Ooh, I love this question. So to reiterate, within an AWS region, which if you haven't used AWS, it's like a data center, or it could be multiple data centers actually. AWS guarantees you though, that everything in a region will be close enough and connected, well connected enough to ensure super low latency between those zones. So an AWS region has network, very, very fast network between all of the buildings. And I think those buildings are something like 30 or 40 kilometers apart. AWS publishes a number somewhere. But in essence, it's a LAN. It's almost like a LAN because the latency is so low that you could put stuff in US East 1A and US East 1B. And if 1A went down, well, 1B is still going to stay up and running. So back to the question is, can you put Consul servers or agents on different zones? And the answer is absolutely yes. AWS zones within the same region are close enough together and have fast enough, networking that not only can you do it, we highly recommend it. So in the demo here, or in the slide rather, let me back up. Architecture diagram is the word I was looking for. These 3 servers would ideally be in separate availability zones within the same region. So great question. And same goes for any environment. If you can provide that sub 10 millisecond latency, then you can get away with it. The area where we see trouble is people try to cheat. They've got like 100, 200 millisecond latency, and it's just not good for the communication, right? The gossip protocol, it wants to have really fast, small bits of data being passed back and forth all the time. All right, and we've got another question in the Q&A.
Yeah.
Do you want to read it?
Go ahead.
Okay, I got it. This seems like it would work well with the effortless model if you need to replace some of the features of Chef Server where you're searching for nodes of a specific type. Instead, you could put that information in Consul instead. Does that sound like a good idea, and have you looked into doing that? I'm not gonna dodge this question, but I'm gonna say it depends. But let me elaborate on that a bit. There are times during the Chef run where you need to know what other nodes have a certain attribute set or have a certain quality. And maybe I need to pull all that information into a template or a config file. The classic example we always use was a load balancer. The load balancer HA proxy config needs to know the IP addresses of several other machines that are on the network. So the reason it depends is this something that you're building? You need to think about, am I building this now? Do I have to maintain it and manage it in an ongoing way? Or is it more of something that I build and hand over to an application team or another config management tool to keep this file or this config up to date? If you do it in Chef, the advantages are it's more chefy, it's more consistent. You're not relying on an external tool. But the downside is that if you have stuff that changes a lot, or you need more up-to-date data than the half-hour frequency that the Chef client normally runs in, you may want to consider using a real-time, service discovery tool like Consul. So to illustrate that a little more clearly, think about how the Chef client runs. It runs in a cadence. Every 30 minutes, a new snapshot's taken. All that node data is updated and pushed up to the Chef server. So your service catalog, or your Chef, your Chef node list, if you will, it's up to date, but only in terms of the last half hour of activity. So usually things don't move around that much, right? The odds are your app is probably still at the same IP address. If on the other hand, if you need more info, like is that thing healthy? Did the port that it's running on change? You might lean more toward a tool like Consul for those bits of the config. It always is a good practice to sit down and demarcate who is in charge of what. So the chef run, You know, do you want to use it to manage your application configs? Maybe. That might be the right choice. If you're all in, we do everything with Chef, then that's great. But other shops oftentimes use Chef for just configuring so far up the stack. And then those machines are handed over to someone else who puts their own application on top. Both those groups can use Consul, right? So even if the people using that machine later wanted to query Consul without Chef, they could do that too. So that was kind of a long-winded answer. The short version is it depends. And if you're searching for nodes of a specific type that don't change that often, it's probably easier to do it within Chef. If you're searching for data that's more volatile and that could change more often than 30 minutes, in a 30-minute interval, then you might consider parking that stuff in Consul. Great question.
Awesome. There's a couple buried in the chat here. There's one, how does it work with Redis and Elasticsearch clusters where data is sharded? Do the consuming clients need to point to a single DNS service name?
I'd have to defer to my coworker, who he was supposed to be here to handle the tougher questions. I have not used Consul in a sharded environment. However, I can take a follow-up, and maybe we could post it in the follow-up notes for this.
Cool. There was one other one here that I'm actually going to push to another talk. So can you generate a compliance report using Terraform? We actually had a couple of Terraform talks that are also included in ChefConf. So you can search for Matt Ray's talk when they all go to video on demand. He covers some of that stuff in his talk. So.
Great. Thanks for handling that one, Mandy.
Yeah, no worries. Make sure I caught all the ones that were here. Yeah. Awesome. Does anybody else have any other questions or anything else you'd like to know about Chef and Consul before we adjourn?
I've got one last thing since we have a minute or two.
Yeah.
I'd just like to give folks a quick tour of these. These are browser-based, really fun little tutorials. If you'd like to know more about Consul and just get your feet wet and then maybe start integrating it with Chef, you can simply click one of these links and it'll take you to our Instruct learning platform. No login required and nothing other than a browser. So you'll get a real Consul cluster to play with very little investment on your part. So you could do these over a lunch break if you wanted to. And that's it. Bill and I thank you for attending this talk.
For relaxing times, make it Santori time. Oh, there's one sneaky question here in the chat though. Like, what size companies are you targeting for a project like Consul? Like, what kind of implementations do you actually see in the field with that?
Truthfully, it's really huge companies that get the most benefit from this, or small companies with huge networks. It's when you get beyond the point where you just can't keep track of everything by hand, your current configuration database isn't keeping up, then you can really see the value of Consul. So typically speaking, our power users, some of them have 60, 70,000 nodes in spread across multiple Consul data centers.
Yeah, that's a lot. So obviously there's a lot of things they wanted to not manage by hand there.
Yeah, it's our most widely deployed tool. Also kind of one of the things that just runs behind the scenes.
Awesome. Yeah. All right, folks, anything else? Last chance.
Thanks, everybody.
Right. So yeah, if you want to see this video again, it will be available starting next week. Oh my gosh. After the ChefConf keynotes on June 2nd, you can sign up for free at chefconf.io for this video and all the other videos, plus the live stream and the awesome concert and all the other good stuff. So thanks very much, folks.